Hello viewers, welcome to Kids Auto and Truck Repair. Today we have a 2012 Mercedes Sprinter with a 3.0 liter. The driver's complaint on this Sprinter van is the check engine light remains on the dash and the engine is losing power. So the first thing we're gonna do is we're gonna confirm the driver's complaint. After confirming the complaint, we're gonna connect a scan tool to the vehicle to see what kind of trouble codes we have in the engine computer. So now let's confirm the complaint. I'm gonna start the engine. So right there, as you can hear, the engine is running and the check engine light remained on the dash. So right there, check engine light is on. So driver's complaint confirmed. So now I'm gonna turn off the engine. I'm gonna turn the key on. I'm gonna get the scan tool connected and then I'll bring you guys back up. I got the scan tool connected to the vehicle. I'm gonna bring it up. Let's scan the engine computer and see what we got. So we're gonna go to scanner. We have 4 trouble codes in the engine computer. The first trouble code is P15FF00 and it says the learned values for component B28/20 diesel particulate filter differential pressure sensor are outside the permissible range. So it looks like there's something wrong with our pressure differential sensor on the DPF. And then the second code is P15FE00 and it says the signal line of component B28/20 diesel particulate filter differential pressure sensor has a short circuit to positive. So this component B28/20 is the pressure differential sensor on the DPF. And the job of the pressure differential sensor is to measure the pressure difference between the inlet of the DPF and the outlet of the DPF. Okay, so it looks like it's not working well. So the sensor, the DPF sensor is not working well. The pressure differential sensor has a short to power. Okay, and then here, the third code is P15FF00 and it says the signal line of component B28/20, so the same component, diesel particulate filter differential pressure sensor has a short circuit to ground. This is odd because here it says that this component has a short to ground, but up here it says it has a short to positive. Now this can be caused by a defective sensor. I've seen sensors go bad and cause short to power or short to ground trouble codes, okay? Because one harness cannot be shorted to ground and to power at the same time. This is usually caused by a defective sensor. So based on the trouble codes that we have, I can kind of bet that this sensor is going bad. The pressure differential sensor is failing. But we're not just going to replace it. We're going to test it first to make sure the wiring is good. If the wiring is good, we're going to go ahead and replace this sensor. This explains why this van is losing power. Because if the pressure differential sensor is sending a skewed signal to the engine computer, the computer will think like the DPF is clogged and then it's going to reduce the engine power. So the engine is going to go into the derate mode, which will reduce the power output of the engine, and the driver is going to experience some low power while they're driving the vehicle. At this point, with these codes, we can either have a problem in the pressure differential sensor wiring, or we can have a bad pressure differential sensor. And then the fourth code is P11C900 and it says no cam message was received from control unit N30/4 ESP control unit. So it looks like the electronic stability program is not talking to the engine computer. So we're not going to worry about this code right now. We're going to focus on these first three codes, and this code is what's causing these other codes to be set as well. So let's scroll down and see what else we have. We got no codes on these control units, so that's good. 2 codes in the signal acquisition module. 2 codes in the AdBlue control unit. Interesting. Now in this video, I'm going to focus on these codes over here. Okay, the codes inside the engine computer. These codes are causing the check engine light to remain on and the engine to lose power. So on the generic side of the tool, we have the same codes. The first one is P2454, and it says particulate filter pressure sensor A circuit low. And then the second one is P2453, particulate filter pressure sensor A circuit range/performance. Interesting. Okay, so this should be pretty straightforward and pretty easy. Now what I'm going to do is I am going to go to the sensor, to the pressure differential sensor, and do a voltage measurement at the sensor electrical connector. This is a 3-wire sensor. We should have a power and ground and signal wire at the sensor. So now I don't even have to test drive this. What I'm going to do now is I'm going to go in the engine computer. These codes are already saved in the scan tool. So what I'm going to do now is I am going to erase these codes. Let's see if these codes are going to get erased. So let's clear the codes. Let's see if these codes will go away. So we erased the codes. Let's go to codes. Okay, so 3 codes went away and only 1 is staying on. So this P15FF00 is not going away. So let's back out. Let's try to clear this code again. Let's see what happens. Let's clear the code. Let's look at the codes again. As you can see, this code is not going away. So now what I'm going to do is let's go under the hood and do some tests at the pressure differential sensor wiring. Our pressure differential sensor is right here in front of the cabin air filter box. So here is our pressure differential sensor. Now if you follow the tube that go to the pressure differential sensor, if you follow these 2 tubes over here, there's one here and there's another one. Okay, there's this tube and this one. If you follow these 2 silver tubes, they go to the DPF. If we follow them, okay, if you follow this tube, it goes down to the DPF. So these 2 tubes are coming from the DPF. Okay, one is going to be on the inlet of the DPF, and then the other one is on the outlet of the DPF. So we are interested in this electrical connector here, and this over here is our pressure differential sensor. As you can see, we have 3 wires at this connector, and we have a code that says that this component B28/20 has a short to ground. So I'm going to back probe these 3 wires, and then we're going to use a lab scope to watch the voltage that we have on these wires. So these 3 wires, one of them is going to be a ground, the other one is going to be a 5-volt reference, and then the third one will be the sensor signal. I'm going to connect my lab scope to these back probing tools, and then I'll bring you guys back up so we can watch the voltages that we have at these wires. You can see we are back probing all 3 wires at the pressure differential sensor. So now we're going to go to our lab scope. Let's set up our lab scope. Okay, Okay, so we have 2 channels on. I'm gonna turn on the 3rd channel. Okay, so right now we don't have any voltage at the wires of the pressure differential sensor. Okay, there's no voltage there. Okay, we got nothing on the lab scope screen. Now I'm gonna go in the vehicle and turn the key on first and see what happens. So let's go in the vehicle and turn on the key. So the key is on. Let's go back to the lab scope. Now with the key on, we have 5 volt on the yellow trace. So the yellow trace is our 5 volt reference. And then we have 0.02 volts on the green trace. So it looks like the green trace is going to be our sensor ground. And then we have 0.00 on the blue trace. So blue trace looks like it's going to be our sensor signal. Okay, so let's refresh this. Okay, so our voltages didn't change. So now I'm gonna go in the van and start the engine. Let's see if these numbers are gonna change when we start the engine. So right now with the key on, we have on the live numbers, we have 4.99 volts on the yellow trace, 0.02 volts on the green trace, and 0.00 on the blue trace. Okay, so now let's start the engine. And I believe that sensor is going bad because based on the voltages we have at the sensor, I don't think we have a short to ground on the wiring. Okay, so the engine is running at idle. Now we have 0.04 volts on the blue trace. The voltage on the green trace didn't change, and the voltage on the yellow trace just went up a little bit. So now what I'm gonna do is let's go back to the engine computer. As you can see, we still have our trouble code there. Okay, so let's go back to the lab scope. Now what I'm going to do is I'm going to disconnect the electrical connector of the pressure differential sensor. Let's see if our voltages will change. So this is what we have right now at idle. I'm going to disconnect this connector here. So what I'm looking for any voltage rise on the signal wire. Okay, so we got the sensor unplugged. Oh, we lost one back probing tool here. So we got the sensor unplugged. So now let's see what we have on the lab scope screen. So with the sensor unplugged, the voltage on the green trace went up a little bit. We have 0.05, and then the voltage on the blue trace actually went down. We now have 0.01 volts. So based on the voltages that we have right now, this tells me that the wiring of the pressure differential sensor is good. Okay, the wires that connect to this sensor come from the computer. Okay, so these 3 wires over here are coming from the engine computer. All these wires come from the engine computer. the fact that we have 5 volts on one wire and then 0.05 volts on another wire and then 0.01 volt on the third wire, that tells me that the wiring of this sensor is good. Okay, we don't have a short to power or a short to ground on the wiring, so the sensor wiring is good, okay, based on what I see on the lab scope screen. Okay, so there's nothing wrong with the voltages I see. So the problem is the sensor. So this sensor is going bad. I went ahead and got a new sensor from Mercedes. Okay, so since this code is not going away, what I'm gonna do is I'm gonna disconnect this sensor and connect this new one. If the problem is the sensor, after I get the new one connected, we should be able to erase the trouble code on the scan tool. So now I'm gonna get the brand new sensor connected to the wiring. So here's our old sensor. We got the new sensor connected to the wiring. Okay. If our problem is the sensor, now we should be able to erase the trouble code. So the sensor is connected. So now let's go to our lab scope / scan tool. Let's back out. Let's clear the code. Let's read the code again. As you can see, our code went away. No codes present. So the problem was a defective pressure differential sensor. Now, if we go to our lab scope, let's see what voltages we have there. Okay. So our voltages didn't change much. Okay. So, but at least now we can erase the trouble code. So this tells me that we have made the right call. Let's go back to our codes. As you can see, no codes present. Let's back out. Let's see if we can look at some data. Let's go to DPF, diesel particulate filter. So let's watch this. We have 0, on this PID. So I am going to, let's disconnect the new sensor again. Okay, so we know we have made the right call. The problem is a defective pressure differential sensor, because when we connect this one to the harness on the vehicle, our trouble code can be erased. Okay, so we're gonna watch this data PID over here. Let's see if this is gonna change when we reconnect the old sensor. Alright, so I got the new sensor unplugged. Let's put it over here for now. Let's reconnect the old sensor. So with the old sensor connected, here's what we got. We have 0.2 psi on the pressure differential in diesel particulate filter. I believe when the computer sees this 0.2 psi, it flags the code that we have in the engine computer right now. Okay, so if we back out of here, if we go to codes, as you can see now, our code is back. And if we try to erase it, it's not going to go away. Let's go to clear codes. Let's go to codes again. So we cleared the code, but our code is not going away. Okay, so now let's reconnect our brand new sensor. So we're gonna do this again. Let's connect our brand new sensor, and now our code is now gonna get erased. So we got the sensor, the new sensor connected. Okay, let's go to the scan tool. Our code is still there. Let's back out and clear the code. Let's read the code. Right there, no codes present. Okay, so this is fixed. This needed a pressure differential sensor. Okay, now the speed is showing us minus 0.0 psi. So now what I'm gonna do is I am going to install our new pressure differential sensor on the vehicle. I'm gonna undo this nut. I'm gonna disconnect these two tubes down here. I'm gonna connect them to these two tubes here on the sensor. And then we're gonna take this van for a test drive. And I'm sure after that, the van is gonna drive a lot better. And then we're gonna wrap up this video. I'm gonna get our brand new pressure differential sensor installed, and then I'll bring you guys back up. This is very straightforward and easy to install. I'm gonna undo this nut, and then I'm gonna connect these two tubes. You cannot interchange these tubes because one is smaller than the other. As you can see, this one is bigger and this one is small, okay? So it's very easy and very straightforward to replace. I'm gonna install the new one, and then I'll bring you guys back up. So the sensor is installed. We got a brand new pressure differential sensor there. So now let's take this vehicle for a test drive. So as you can see, the check engine light went off. So that's good. So now let's drive this van. We're driving, the van drives well, the van has a lot of power, and the check engine light is off on the dash. So this is good. This is fixed, guys. We got it fixed. So we're gonna go up this hill over here. Let's see how fast we can go up this hill. So we're doing about 50 miles an hour on this hill. Wow. So check that up. This is fixed, guys. We went up that little hill. We were doing about 55 miles an hour. Right now I'm doing about 55 miles an hour. Wow, this vehicle has a lot of power now. This is good. This is fixed. So now I'm gonna drive back to the shop, and when I get back to the shop, I will bring you guys back up so we can wrap up this video. So see you guys at the shop. All right guys, we are back at the shop. This is fixed. The van drives well. The check engine light did not come back, so we're good to go. Now I'm going to bring up our scan tool. I still have the scan tool connected to the vehicle, so I'm gonna bring it up. Let's go into the engine computer. Right there, no codes present. So we're good to go, guys. This is fixed. I'm gonna get my scan tool out of the way. This Sprinter van is fixed. I'm gonna leave this right over here. The problem on this Sprinter van was a defective pressure differential sensor. I hope you liked the video. If you liked the video, give it a thumbs up. If you don't like the video, give it a thumb down. But if you do, you gotta tell me why so we can make better videos in the future. If this is your first time here, subscribe to the channel. Ring the bell so you can get notified every time I upload a new video. If you have any comments, questions, criticism, leave them in the comment box. Thanks for watching. See you next time.